Hello friends, if you already watched the part 1, in the second part of the series, where we analyze an industrial object and start modeling it geometrically, we will try to combine cylindrical body structures from different angles and provide a fluid geometric continuity. Let's start if we are ready to discuss the geometric continuity and surface evaluation. The next thing I will do is blend the curves and make sure that the blend option has been set as tangent. Important thing is used as tangent continuity. But first, you should not forget to activate Extract Wireframe command. This command will create 2D reference drawings from geometric shapes, and then we will use these lines as auxiliary lines to create our paths for surface meshing with the Blend Curve command. So we got all of those lines, and then I'll type in Blend Curve Select. The first curve, second curve, and make sure that you select the tangency. Same right here, this curve and this curve, hit OK. This curve and this curve, hit OK. Same on the top, this curve and this curve, hit OK. I will select all those surfaces. I will open from the Analyze menu to show naked edges. I'll click Show Edges and we see that there's this little knot. Knot will help us as guidance to split the edge later steps. In order to do so, we will click this tool, Split Edge, and I'll select those surfaces or select those edges to split. Split from this point to this one, hit OK. And now I'll hit Space, select this curve, this point, and this point, and this point, hit OK. Also, I'll do it on this curve, this point. OK, make sure that you only click this one, and this point on this one, the one with the smallest diameter, OK. And then I will start to type in Sweep 2. I will select the first rail, second rail, and the first cross section and second cross section. See, the reason why we split those curves, or those edges, is because otherwise we cannot select this segment as our cross section. At this stage, we will join the outer edge of the surface created with the Sweep 2 rail and the edge of the handle circle by weaving a surface. During this joining process, we must be careful to use the surface blend command and keep the curvature as transitivity. After this stage, we will use the Sweep 2 command sequentially to create the path and cut we created earlier. Perfect, so after completing all of this, before doing anything else, let's do a surface transitivity analysis called Zebra. See the continuity of the surfaces and answer any problems we have. After the surface knitting process is completed, when we run the tool that shows the surface continuity named Zebra from the Analysis menu, it can be seen that there are some continuity problems. In order to fix the surface continuity problems, we have to do some procedural things. So, first things is, we have to refit the surfaces. I'll explain to you in a second. Let me explode that first, all the geometric shape as single surfaces. Then select all of the surfaces, and I will come over here find a tool called Refit Surface to Tolerance. I'll click it. Then right here it says fitting tolerance is 0.1, and I will type in Enter. I got it. So what this refit is doing is basically simplify the ISO curves and control points on this surface, but at the same time to keep it as close as possible to the original shape in the old surface. For this purpose is called a fitting tolerance, and we set up as 0.1 here. That's great. Then let's go back to our instructions. Here it says repeat surfaces 16988. Let's explain what is 16988. I'll select all of those surfaces and I'll type in reviewed. So in this reboot here, it says point count on the U direction. There is no such number. On the V direction, it is 3. Okay, what do those mean? Is that, for example, on this specific surface, it says on the U direction, there are 18 control points and there are 3 control points on the V direction, and the degree is 3 and 2. Okay, so those numbers in the parentheses are its original state. And the numbers right here, the number that you can change is a target number. You only add more control points here on U direction, add more control points in the V direction, so on and so forth, and then you can change the degree. Okay, so we explained those earlier. The higher degree means that higher smoothness and more control points. Again, it just gives you more controls, okay? I'll explain why we need more controls in just a second. direction, they don't have the same number. But on the other things, you have all the same numbers. So the parentheses show such thing. And please make sure that the U direction has 16 control points. V direction has 9. The degree, we have 8. And there is no such magic formula for you to decide numbers. Over here, it's all based on your experiences, and for this specific case, please just use a number that I provided. And I'll hit OK. Give it a second. Okay, we've got the new surfaces, but before we go back to the specific instructions, I'd like to end our part 2 video here. After you've built up your experience up to this point, let's discuss in part 3 how to knit the surface here and how the discrete surfaces relate to each other. Thanks for watching, and see you in the next video.